All right, now let's do this example here. Now, in this example, if you're looking at this example, look, they already got one of the variables, or excuse me, one of the equations already solved for one of the variables. So I would use the substitution method in this case. I wouldn't do, why do the extra step of getting it into the right form to use the addition method when you can go right to the substitution method, because I can take this and plug it in for y and just write this as 8x minus 4 times the quantity 2x minus 1 is equal to 4. And now I can just solve, right? So now it's 8x minus 8x plus 4 equals 4, right? Oh, and look at that. These drop out again, and now I get what? 4 equals 4, which is a true statement. That is always true, right? So what does it mean? What does this mean? This means that this is a dependent. The equations are dependent on each other. There are infinitely many solutions. Okay, so how would I write this solution set? Well, since I know that y, and it's here, and you can also see it this way too, is if I write this in the right form, let's write it in the standard form, okay? So if this is y, let's write it, so it's going to be negative 2x plus y is equal to negative 1, and then this one was 8x minus 4y is equal to 4. Now, notice that you might note this equation is just a multiple of this equation, because if I multiply this by what? Negative 4, I get this equation. So guess what? Those two represent the same equation. They're two lines that are basically right on top of each other, and so they're going to have infinitely many solutions. Okay, so that's what I mean. These equations are dependent. They're basically representing the same line. Okay, but let's go back to how do we write the answer, right? How do we write the solution set? So here they're telling you, well, in this case here, y is equal to this. So what we could do is we could use a parameter. We could use x as what we call the parameter, and we could say, hey, x can be free to be anything, right? So what we'll do is we'll write the point as a ordered pair where, where the x value can be whatever we want. So we'll just say x. We'll just put it as x. But once we choose x, y is defined by this rule. So we're going to use this rule as the other part of our ordered pair, and we're going to write 2x minus 1. And so now this is how we write the solution set, right? So it would be the set how do I want to write that? For all x right? So for all x, I just want to make sure I write this right, different ways. So the set of all points of this form such that x is any real number. Okay? And so now I use a boldface R, which represents the reals. That's a common symbol. Or you could just write it out such that this vertical line means such that. So the set of all points of this form such that x is any real number. Now you can write it out, x is any real number, or you can write it these symbols. This is x. This symbol here that looks like a little, funny looking e is it means an element of, and so x is an element of what? The real numbers. Okay, so this symbol represents the set of all real numbers. So you could use that symbolism, this one here, or just write it out in words. I don't care. You don't have to know the symbolism for this class, okay? But you do have to know that, hey, I've got to write it in this form. So set notation is important. You got to have the set notation. And then this vertical line means such that. Sometimes you use a colon. A colon or a vertical line, same thing. So such that x is any real number, okay? And that's it. So now you've seen examples where you got either a unique solution. We've seen several examples of where you have a unique solution. We saw an example of where you had no solution, where the system was inconsistent. And then now you've seen an example where you have infinitely many solutions and thus the equations are dependent.